Okay, my name Claudio Stockle, Department of Biological Systems Engineer at WSU. I have names of members of the core team, collaborators, links. The idea was everybody will speak here in 7 minutes. We decided at the end maybe it wasn't a good idea, so I'll be the only speaker in this case. The objective and the charge for my team in this project essentially is to make an overall assessment of yields, greenhouse gas emissions, budgets of nitrogen, water, and other matters, and inform to a number of other groups about outputs that we obtain through the simulations. So we're really linked with almost everybody, and some people we talk about linking, and we haven't done so yet, but it will happen in the next year or two. We're doing this on a regional basis, as you can see there, and it's based also in the definition of AEZs that have been provided by Dave Hagen's group. There are some issues with that definition, not so much about the present, where we have information, but in the future, where we don't know how to deal with it. We can have biophysical definitions of it, but the socioeconomical definition of those zones is a little bit more challenging. We're using the weather essentially that John Abasa, Glue, and others are producing, and we're using essentially a projection from 12 different GCMs. It could be maybe up to 14 when we're done with this. And when we started, we were naive enough without going to be doing one or two, okay? Things are changing fast. We use the CropSys model that we have developed in our team to run simulations. This is an example of the kind of output that you get, and you have baseline, the 2030 period, the 30-year that is centered around 2030 and 2050. If you inspect those with some degree of care, you won't be able to see here. There are some little changes, but they are not huge changes. But when you look at this more in detail, you see things like this. On the left-hand side would be historical yields. Now, these are based on historical projections of weather. There are issues there also that we may need to talk about. Then you have projections there for using 4.5 and 8.5, essentially CO2 emissions. And in the upper quadrant there, you can see there the dilemma that we have. You have one of those lines at the bottom represented there, but now we have error bars. These error bars in Excel, I'm not so sure, I think they're 1 plus up minus 1 standard deviation. I think that's the error bar. I'm not 100% sure about that. But you can see the tremendous variability that there is there, because the lines that are here at the bottom are means of 12 GCMs. And because they are means, also, the variability that you see is less than you see in the baseline. So how we're going to make an interpretation of that variability is a real challenge. You can see this also from a different perspective. This would be emissions. You have a change of carbon. We've been losing carbon historically in conventional tillage systems. Because of warming, we're going to see an increase 2030, 2050 of that. And in terms of emissions related to nitrous oxide, there's going to be a little bit of a decrease in the means here. I'm not so sure if this is correct, actually. There is a little bit of a decrease, and this is because there is a little bit of increase of yield with the same amount of nitrogen being applied to the systems. So in terms of the total emissions, then, there is an increase in time. Yields don't change much. The 2030, they will change a little bit of a gain. This is winter wheat in a system of crop and fallow, okay? So it's a very simple system, and there is some advantage in that system that you can detect for winter wheat. That's good news, but there is a tremendous variability about this in a variety of different ways. One way to look at that is distribution. In this case, we're looking at the greenhouse gas emission. Next will be yields. But there is a shift, but in general, this is historical, projections tend to show anywhere in the distribution higher emissions for this particular system. And then you have, for yields, kind of the same story, a little bit lower yields here for this particular scenario. So I want to get to this, and there are connections to a variety of different topics within REACH that are already ongoing. Others need to be developed, and we have talked about that. And the other thing that I want to emphasize, there are also a lot of interactions outside REACH. I'm part of a consortium of European community for a proposal for weather, extreme weather impacts in agriculture that we're expecting to be funded at the end of this year. We're crossing our fingers. We're part of AgMIP, which is a network of global modelers that are involved looking at the effect of different GCM and different models in predictions. We have, with this I think I finished, we have a meeting last week of programmers for AgMIP. We learned that there is a system available in Austin. It's a supercomputer essentially. Hopefully we're going to have access to that. Maybe we're going to be able to bring not only one model we're using CropSys, but bring maybe 3, 4, maybe 5 models that have crop system capabilities around the world. That would be great if we can do it. Time's up.